All plants emit some methyl jasmonate when they're attacked by insects. So that appears to be a word that occurs in all languages.
For centuries, we believed plants were quiet, passive beings, just standing still, unaware of the world around them. But what if everything we thought we knew was wrong? A breakthrough using AI has uncovered a language that plants have been speaking all along. And it's not a calm whisper, it's a cry for help. What have they been trying to tell us? For as long as we can remember, we viewed plants as peaceful, almost passive beings, rooted in the ground, growing slowly and quietly reacting to the world around them. We admired their beauty and relied on them for oxygen, food, and shelter, but we never gave them much thought beyond their visible growth. A tree's bark, a flower's bloom, the sway of grass in the wind, everything seemed calm, still, and ultimately silent. But what if the silence we've always heard is not the full story? What if all this time, plants have been speaking to us, broadcasting their feelings and needs in a language far beyond our perception? What if their stillness isn't a sign of peace, but of something much more complex and terrifying? New scientific breakthroughs have shattered the old view of plants as silent creatures, and the message they've been sending all along is far more urgent than we ever imagined. The silence was broken by an unlikely source: artificial intelligence. Researchers using cutting-edge technology set out to listen to plants in a way no one had before. They placed non-invasive ultrasonic microphones near tomato and tobacco plants, microphones designed to detect high-frequency sounds, far beyond the range of human hearing. For days, the chamber was still. The plants remained quiet, giving no sign of distress. But then the researchers introduced stress. One group of plants was deprived of water, another had its stems carefully snipped, and that's when the unexpected happened. The silence shattered. The plants began emitting short, high-frequency popping sounds, ultrasonic clicks, imperceptible to the human ear, but clear to the AI. It was a language, a form of communication previously unknown to us. The plants weren't silent after all. They were speaking. And what they were saying, what they were trying to tell us, was nothing short of alarming. The ultrasonic clicks that plants emitted weren't random noises. They were specific cries for help, each one signaling something different. These sounds, ranging between 40 and 80 kilohertz, were outside the human hearing range, but the AI could detect them and analyze them. What researchers discovered was astonishing. A stressed plant, such as one deprived of water, emitted a distinct clicking pattern completely different from a plant that had been cut. Using AI, the team trained a machine learning algorithm to decipher these acoustic signals. The results were clear and precise. The AI could tell, with about 84% accuracy, exactly what kind of stress a plant was experiencing, whether it was thirsty, injured, or otherwise in distress. For the first time, we were hearing the plant speak, and the message was clear. Their survival depended on how well we listened. What followed would change everything we thought we knew about plant intelligence and communication.
What made these ultrasonic clicks even more shocking was their urgency. Plants were not simply making noise, they were sending out distress signals. A thirsty tomato plant's click sounded different from a dehydrated tobacco plant, with each plant species having its own unique accent. These weren't just random bursts, they were carefully crafted cries for help, each one signaling a specific need. Researchers discovered that a stressed plant could emit between 30 and 50 of these ultrasonic clicks every hour. Healthy plants, on the other hand, remained almost completely silent. This wasn't just a random sound. It was a deliberate communication, a message to the world around them, warning of their condition. And here's the real revelation. These clicks weren't just a passive reaction. They were a calculated form of expression, an attempt to reach out, to inform others of their suffering.
But it didn't stop there. The implications of these cries were far greater than anyone could have anticipated. As groundbreaking as these ultrasonic clicks were, they revealed only a fraction of what plants were truly capable of. It turns out plants weren't just silently suffering alone. They had an entire underground network, an intricate web of communication, connecting them across vast distances. This network, known as the Woodwide web, is made up of fungal networks that link the roots of trees and plants, sometimes stretching for miles beneath the soil. For decades, scientists believed this system was largely passive, a simple means for plants to share nutrients. But with the new AI technology, a darker, more complex picture emerged. The ultrasonic signals we heard weren't just cries of distress. They were part of a highly coordinated system. When one plant was in danger, others responded. This wasn't just cooperation. It was a strategic defense system built into the very fabric of the forest. But this unity wasn't always peaceful. Sometimes, the plants weren't just sharing, they were fighting. This wasn't just a reaction to stimuli. It was a memory of past interactions. The plants knew who had nurtured them and who had harmed them, and they broadcasted their reactions based on these memories. This discovery raised an eerie question. How much do plants know about us? The implications of plant memory and communication are profound, especially for agriculture. Imagine a world where farmers no longer have to wait for their crops to visibly wilt before taking action. With AI-equipped sensors, plants could tell us when they are thirsty or stressed long before their condition becomes apparent. This ability to detect plant distress early could revolutionize irrigation, helping farmers conserve water, reduce waste, and improve crop health. But the potential doesn't end there. Understanding plant communication could lead to more sustainable farming practices. By learning when plants need specific nutrients or when they are at risk of disease, farmers could time interventions more precisely, reducing the need for harmful pesticides and fertilizers. The AI's discovery doesn't just promise to improve crop yields, it could help create a more efficient, eco-friendly approach to farming, where plants' needs are met before they reach the point of crisis. But there's still one question lingering. If plants can communicate like this, what else are they telling us? As scientists continued to analyze plant communication, the scope of their findings grew far beyond individual plants and farms. Using AI, they began to monitor plant distress signals on a global scale. And what they discovered was both startling and terrifying. The plants were not just reacting to localized threats, they were broadcasting synchronized distress signals across entire biomes. When large-scale environmental disasters occurred, such as wildfires in the Amazon or extreme heat waves in North America, the AI detected a coordinated uproar from plants across the affected regions. This global network of plant communication wasn't just a response to immediate threats. It appeared to be an ongoing, real-time monitoring system of the planet's health. The plants were aware of the environment in a way we had never understood, feeling the impacts of deforestation, climate change, and pollution long before we did. It was as if the Earth itself was trying to warn us, but we couldn't hear it. And now, the plants had a message for us. They were listening, and they were suffering. The discovery that plants could communicate on a global scale opened the door to a chilling possibility. Plants weren't just reacting to their immediate surroundings, they were responding to the broader environmental crises caused by humans. As researchers fed AI models with planetary-scale data from satellite sensors and acoustic recordings, a disturbing pattern emerged. The plants seemed to be coordinating responses to climate disasters, such as severe droughts and forest fires, through their underground networks. The most terrifying part, the plants appeared to be geoengineering the climate. AI analysis showed that in response to rising temperatures, entire forests released volatile organic compounds, chemicals that could trigger cloud formation to cool the atmosphere. It wasn't a passive reaction, it was an active, desperate attempt to manipulate the planet's weather patterns, a fight for survival on a global scale. For the first time, we understood that the planet wasn't just being destroyed, it was fighting back. The plants were not only aware of our actions, they were actively trying to counteract them. And the message was clear: we were damaging the very system that sustains us, and the planet was starting to fight back.